Today we are going to look at some special case trinomials and how to factor them. And so what we're trying to do here is determine whether a trinomial is a perfect square, because if it is, it'll make it a lot easier to factor. So if it is, we're going to go ahead and factor. If not, we will explain why it's not. So let's take a look at what a trinomial square is. Basically, the first term and the last term must both be positive. So this is going to be a perfect square, and it's got to be a positive number here. And this one here as well has to be a perfect square, and it has to be positive. And the reason is that what we want are two binomials that are exactly the same. So for instance, x squared. The numbers that multiply to make x squared that are the same are x and x. See, x times x makes x squared. And the numbers that make 9 that are the same are 3 and 3. And so what we want to do here is have exactly the same binomial. And so far we do, but we need to make sure they have the same sign. So that's why both of them need to be positive. Because if this were a negative number here, that means they would be opposite in sign. Well, both of these are positive, and what we want to do here to make sure it does work out is the outer and inner terms need to add to make this number. So here we have a 3x, and here we have a 3x. And notice that when we have a trinomial square, when both binomials are the same, that means that the inner and outer terms are always going to be the same. And they should, if we have 1, since they're the same and they add to make a number, if we have 1, we can double it and get that number. And so this does work out. This is a trinomial square. So the way we can write it is x plus 3 quantities squared. So the reason why we want to have an extra section on this is so that when we see some trinomials that may seem difficult to factor, they might end up being trinomial squares. And so for instance, on this first one here, if I look at the first term, 4x squared, this is a perfect square. So is 1. That's a perfect square. So if I was to factor this, I would think of what is the square root of 4x squared? Well, that's just 2x. See, 2x times 2x makes 4x squared. So that would be the first numbers in each of the binomials. Same thing here. If I took the square root of 1, that equals 1. So that means that these two numbers need to both be 1. Well, they have to multiply to make a positive, so that's good. And that means they're the same sign, but they have to add to make a negative. So I'll put two minus signs here. But always check the outside terms and inside terms to see if they indeed do make that middle term. So both are the same again, and that will be the case on all trinomial squares. And they do make negative 4x, so it does end up working. So we have the answer. So the factored form would be 2x minus 1 quantity squared, because there's two of them that are exactly the same. So, for instance, on this one, though, we take a look at the first one, and it is a perfect square. See, if I was to take the square root of this number, that would be just 6x. And this is a positive number, which is good, and if I took the square root of it, it would be 1. So whenever I see the first and last term being perfect squares, my first try on factoring is going to be a trinomial square. I'm going to think of it as the two binomials being exactly the same. So I'll try 6x and 6x, 1 and 1. And now I need them to multiply to make a positive, but add to make a negative. So that means both signs are negative. But you always have to check your inside and outside terms to see if they do indeed add to make that middle term. In this case, negative 12x, which they do. So we've got the answer, 6x minus 1 quantity squared. So far, the first two have worked out, but not all will work. So let's take a look at the next one here. And we look at the first term and the last term. If these are both perfect squares, then my thinking is that it's going to factor as two binomials that are exactly the same. It's going to end up being a perfect square trinomial. And so I'll go ahead and draw my two parentheses and try 5x and 2, 5x and 2. And I see that this is a positive 4, so that means that yes, indeed, it does end up multiplying to make a positive, so that means they're the same sign. Now they add to make a positive, so that means they both be plus signs, and we got to check those outside and inside terms to see if they add to make 10x. Well, we've got a problem here. See, the inside make 10x, the outside make 10x. That means those add to make 20x. So what that means is that this is not going to end up factoring, and this is not a trinomial square. So we have to explain that. Not a trinomial square And the reason is that the middle term, the b term, is 20x, not 10x. So that would be an explanation for us here. And so it just didn't end up working out. We checked the outside and inside terms, and it showed that they did not add to make the middle term. Well, let's take a look at the next one. So far, so good. We've got a perfect square and 9x squared and a perfect square with 9. So this makes 3x, and this makes 3. So let's try those numbers. Let's try a 3x and a 3 to see if that ends up working. Well, the next thing to do is to look at the middle term, and it's negative, so that tells us both would have to be negative if this is going to end up working out. Well, the first terms make negative 9x, the second terms make negative 9x, and remember the trinomial square, both terms will be the same. And so if you double one of them, you'll get the middle term, which is negative 18x, so it does end up working out. So 3x minus 3, that is the answer. It's a quantity being squared. Well, let's try the next one. Well, so far so good. 4x squared, that's a perfect square, makes 2x. 1's a perfect square, makes 1, but there's a problem. Where's the problem here? Well, the problem is right here, this minus sign. That's the problem, because we can't have two numbers that multiply to make a negative that are exactly the same. So that's the problem, is that the last term is negative. So it's not a trinomial square. And so the first and last terms have to both be positive for it to be a trinomial square. Well, taking a look at the next one here, this one looks encouraging. We've got a 16x squared, which makes 4x if I took its square root. 25 makes 5. Both are positive, so we think it might end up working. So let's try it. Let's try 4x and 5. 4x and 5. And so we'll go ahead and take a look at what the sign should be. They need to add to make a negative, so we'll put minus signs, and we just check those outside and inside terms to see if they do make negative 40x. So once you have one of them, though, you know it ends up working, because negative 20x times by 2, if I double it, it makes negative 40. You see, if I just double it, it works because both of these have to be the same for a trinomial square. And that does make negative 40x, so it works. So 4x minus 5 quantity squared is the answer. So the reason why we take a look at trinomial squares specifically is because it's just another factoring strategy. If we see a trinomial and we see the first term and last term are both perfect squares, we try it as a trinomial square. If they're not, then we'd factor another way. Well, those are some of the problems you'll see on tonight's homework. Good luck.